Studios production. Alright, this is going to be the quiz video for Chapter 8 of the ITGS textbook. It's going to be on models and simulations for Chapter 8. Same introduction as before. All of these questions are straight from the textbook, and again, as always, the questions presented first, so write down your answers to those and then compare them to the answers that will be presented next. Alright, here we go. So, first question in this Chapter 8 quiz video. Computer models are used in a variety of scientific areas. To what extent do computer models help or hinder our understanding of scientific concepts? Go ahead and write down your response. Okay, the second question is a multi-part question. It says, computer models are often used to predict the future climate of Earth many years into the future. So, part 1. Define the term computer model. Describe 2 variables that would be included in a climate model. Part 2. Explain 3 reasons why using a map or a graph for the model's output would be preferable to a list of numbers. Part 3. Evaluate the decision to base government policy on the results of a climate model. Take some time now to write your answer. And the third question is another multi-part question. Formula One racing teams often use simulators to help their drivers familiarize themselves with the cars and the tracks. So, part 1. Define the term parallel processing. Describe 2 output devices used by such a simulator. Part 2. Explain the advantages to the team of using simulators in this way. Part 3. To what extent can the use of a simulator remove the driver's need for real-life testing? Record your response, and we'll get on to the answers. Okay, so going through with the answers to these questions, and the first one really did kind of blend in with the second. But computer models and how they either help or hinder our understanding of scientific subjects. Most of the time, computer models are usually a benefit to our studies of the sciences because a lot of times they help us analyze events in sciences that have already happened and can't happen again, or that would be dangerous if they were to happen. Again, for instance, I don't know. There's an example on the slide. In astronomy, computer models are used to simulate, movements of planets and position relative to the sun and other stars. And so sometimes astronomers study the life cycles of stars, and the emission of supernovas. And so if a supernova were to occur too close to Earth, it could be dangerous. But computer models help to simulate space almost, and help to analyze all the other celestial bodies out there. Also, geology even studies, the geological characteristics of the Earth, such as, earthquakes and movement of tectonic plates. We don't actually want earthquake to happen, but computer models can help us analyze what would happen if one were to occur. And that's especially helpful in looking at, if structures would be able to withstand it, how much damage would be caused, etc., etc. Okay, so the second question, part A. Definition: a computer model is a computer program which creates a simplified mathematical representation of a real-life process. The variables depend on the type of models. For instance, a structural model analyzing the structure of a building might analyze weight of materials that make a building and whether or not the structure would hold up under certain types of weather. Part B's answer. Maps and graphs can help not only in the analysis of specific data, but also in the relationships thereof. Graphs and charts can illustrate quantities of data and ranges in relationships, rather than a list of numbers which shows single discrete data points. The third part. Government policy on future climate changes is very important. On issues such as global warming and glacial melting, governments have created policies such as emission control. While computer models are not the most accurate, they are the only way to know true climate changes before they happen. If we waited till a drastic rise in sea level to start controlling global warming, it would already be too late. Okay, and then the answer to the third question, that was the Formula 1 question, my favorite question in the book. Answer to part A. Parallel processing is the use of more than one processor at the same time on a complex task to complete it quicker. More processing power can process more data. In the Formula 1 simulator, a monitor would obviously be used to simulate visual perception, and calculations would help to display mathematical figures related to stats, such as tire wear, average speeds, average fuel use, car setups, and aerodynamics. Part B. The simulators can help provide the visual and physical experiences and requirements of racing without the need for real-life testing. Some models even have computerized models of cars that show how they will behave when making certain turns under certain conditions. This can make for faster and easier tuning changes in preparation for races. And the third part. Since these racing simulators can bring so much realism of an actual Formula 1 race through a computer, the drivers do not need to take real cars for testing. First of all, computer models help to make tuning easier until a right model is found, rather than making physical changes to the car each time. Also, drivers do not need to risk potential damaging or crashing the cars should a real-life anomaly occur.